Hi guys, today we're going to be talking about basic rules and notation of integration. So let's look at more closely what an antiderivative is, and I'm going to write the following statement. G of x is an antiderivative of f of x when g prime of x equals f of x. And that makes sense, and we'll see why in a second. So for instance, x to the fourth over 4 is an antiderivative of x cubed because the derivative of x to the fourth over 4, or ddx of x to the fourth over 4, equals x cubed. And we know that from the basic rules of derivatives. So, that is what an antiderivative is, and we can represent it like this. The integral of g prime of x dx equals g of x plus c. So in this case, I would say g of x is an antiderivative of g prime of x because g prime of x equals g prime of x. Well, that makes sense. And we add this constant c on because whenever we evaluate an integral, to get back to what's inside the integrand from this result, we take the derivative of this. Now, when I take the derivative of g of x plus c, I get g prime of x plus 0. So we have to add this c here because we don't know if a constant could be in that integral. We don't know if a constant could be in that integral. C may just be 0, and we'd still get g prime of x, but c could also be 5, and we'd still get g prime of x. So we need to add that c on to let the integral know that there is a possible constant value there that we can have. So, for instance, the integral of the derivative of e to the x squared dx is simply e to the x squared plus c. Or I could write the integral of 2x times e to the x squared, which is the derivative of e to the x squared dx, equals e to the x squared plus c. So, now let's get into the most common rules of integrals. The first rule is that x to the n dx, where n is some constant and n does not equal negative 1, equals x to the n plus 1 over n plus 1 plus c. N does not equal negative 1. This is called the power rule. Then we looked at this in another video, the integral of k dx, where k is some constant, equals kx plus c. Now, I want to elaborate on this rule a little bit and why it works. From our properties of integrals, we know that we can take out this k and put it in front of the integral. So then I get the k times the integral of, and there's an imaginary 1 here, dx. Now, what if I use the power rule on 1? Well, I can express 1 as being equal to x to the 0th power. So now I'm going to say I have k times the integral of x to the 0th dx. Now I'm going to use the power rule. That's going to be k times x to the 0 plus 1 over 0 plus 1, which equals kx. And then we always add our plus c. And that's why this property right here works. Next, I can say that the integral, and we already did this one also, of f prime of x plus g prime of x dx equals f of x plus g of x plus c. And that's based on the sum difference rule that we expanded on in a previous video. And then the last one, which I just mentioned, is the integral of a times f of x dx equals a times the integral, I can bring that out front, of f of x dx. So these are our common rules. And then we also talked about antiderivatives. And in the next video, we're going to do some examples of application of these common rules.